Question 9 is back to when we talked about simulation, and I want to represent this happening with technology or drawing slips of paper or something to test a claim, essentially. So Wilt is not a good free thrower. In the past 3 seasons, he only makes 56% of those shots. He goes to a clinic and he goes up to take 50 shots and he makes 34. When you take 34 out of 50, that's 68%. That's not 56%. But what I want to know, is it just a fluke? Does that just happen by chance? Or do we have evidence to say he's not a 56% shooter? So what we do is whatever they're claiming, which in this case is 56%, that's what we'll assume to be true to create our simulation. So we want to mimic making a shot 56% of the time. So when I read through these, I want to have basically 56% of values I generate representing making a shot. So I don't want to have 34% making a shot. It's not saying that 34, that has nothing to do with it. That's what actually happened. I don't care about what actually happened. When I set this up, I want to mimic what they're claiming will happen. So they're claiming it'll happen 56% of the time. So that leaves me with C or D, or possibly E. And when I look at it, let's see, C and D both say that the numbers 1 to 56 represent making a free throw. So far, so good. The rest of the numbers to 100 represent missing a free throw, which makes sense. If you make 56%, then you have the complement of that being the missed free throws. And it says generate 50 random integers, and here's the difference. Oh wait, no, I'm on the wrong line. 1 to 100, or 1 to 100 with no repeats. So no repeats needs to represent when you select somebody out of a class, or you draw a card out of a deck and you don't put it back, or you draw a Scrabble tile, or there's something about when you select it, it has been used up and you don't want it to be selected again. I'm wanting to represent 56% of the time he makes a free throw. So if my calculator spits out a 2, it represents he made a shot. If it spits out a 2, that's still okay because it's representing him making a shot. It's not like he can't make that shot again. So repeats are allowed. That's why it's not D. So we're getting values. The reason we're doing 50 values is because we are mimicking what happened in real life. We're trying to see, okay, he made 34 out of 50. If we assume it's 56%, how many out of 50 will we make? So then we will count the number of made free throws and we'll repeat that process many times. So C is the correct answer for number 9. Number 10 I'm going to go ahead and do right now because it's so related. So we've done this simulation. So we get these numbers out of our calculator, it spits out values, and we kind of analyze them and see, okay, here's what happened this time, here's what happened this time. So I see on this dot plot, for example, there is one time where he made 36 out of 50 shots. There was one time where he made 17 probably out of those shots. So variation happens. It's just random chance. They repeated these simulations 100 times. And again, this is simulating 53 free throws because they got 50 values with a probability of 0.56 of making it. Which of the following is an appropriate statement based off the dot plot? So again, I'm testing what actually happened. What actually happened is he made 34 shots, which is a simulation that actually happened in the simulation. There were 3 values that were as extreme as what happened to Wilt or more extreme. 3 out of 100, it was at least 34. At least what happened to Wilt had happened in the simulation, which is really statistically small. So if we're assuming that Wilt is a 56% free throw shooter, then the probability that this happens to him is only 3%. It is not very likely that what happened to Wilt would happen if he really is a 56% shooter. It's much more likely that he's not 56% because it's such a small likelihood of getting that high of a result. So that's how we interpret it, is answer A.